Hey everyone, we are Group 20 and we are excited to present our opinion search engine centered around cryptocurrency exchanges as part of the SC4021 course. We chose this topic due to the surge in public interest following Trump's re-election and heightened concerns after the 2025 Bybit breach. With trust in crypto exchanges wavering and opinions scattered across forums like Reddit, there's a growing need for a tool that consolidates sentiment and insights in one place. Our search engine helps users explore and analyze real experiences shared by the community, making it easier to evaluate platforms based on issues like security, fees, and customer support, ultimately supporting more confident and informed trading decisions. The following topics will be covered in our presentation. Here are our team members and the roles they played in bringing this project to life. We selected 7 popular cryptocurrency exchanges as our focus for opinion crawling, ensuring a well-rounded view of user sentiment across major platforms. The exchanges are Coinbase, Binance, OKX, Kraken, KuCoin, Crypto.com, and Bybit. Our crowd corpus draws from diverse sources, including 13 cryptocurrency-related subreddits, as well as user reviews from Trustpilot, Apple's App Store, and Google Play Store for each of our 7 selected exchanges. After data cleaning and balancing, we are left with a corpus with about 47,000 records, a total of approximately 1.67 million words, and about 49,000 unique words.
Next, we use Apex Solar to index our crowd corpus, as well as get API requests via HTTP calls to retrieve results in JSON format. For key indexing and querying innovations, the spell checker provides suggestions on misspelled words in the query based on leveraged line edit distance and suggests corrections for misspelled queries, improving usability. Next, text analyzers like Text General support stemming, synonyms, stop word filtering, and lowercase normalization, making searches like trade and trading match seamlessly. Thirdly, a user relevance feedback mechanism is implemented that tracks cumulative scores for each document based on user interactions. Thumbs up increases the score and pushes the result up, while thumbs down decreases it. Lastly, users can also refine results by platform, time frame, content source, and sentiment scores.
To build our evaluation dataset, we took a random sample of 1,000 records and manually labeled them with subjective and polarity labels. We calculated the inter-annotator agreement results between our annotators, achieving 95 and 97% agreement for subjective and polarity labels respectively, far exceeding the required 80%. Afterwards, we induced a majority vote to derive ground truth labels, which serve as reference labels for evaluating our subsequent classification model. We use a hybrid classification approach combining machine learning models like naive Bayes and random forest with rule-based models like Vader and TextBlock. We first use multinomial naive Bayes, known for its simplicity and quick operations. The class level F1 scores of negative polarity classification and subjective classification were high at 0.7 and 0.78 respectively, showing those were reliably detected with few false positives. However, the class level F1 scores for neutral, positive, and objective were low. Next, we tested random forest classification. The results show weighted F1 scores of 0.52 for polarity, 0.63 for subjectivity, which show decent performance of random forest. However, the lower macro F1 scores of 0.4 and 0.56 elucidate that the model is weak at identifying certain classes, in our case, positive polarity and objective classification.
For rule-based sentiment classification, we evaluated both Vader and TextBlock. Vader, which is designed for social media language, performed best when identifying negative sentiment, with an F1 score of 0.68, but had trouble with positive and neutral comments, which brought its overall weighted F1 score down to 0.56. TextBlock was used for both polarity and subjectivity. Its polarity performance was slightly more balanced than Vader's, but still not great, with a weighted F1 score of 0.49. What made TextBlock more useful was in detecting subjectivity. It was better at telling apart opinionated versus factual content and achieved a subjective F1 score of 0.59, bringing its overall score for subjectivity detection to 0.56. So while both methods had limitations, TextBlock stood out more for tasks involving tone or personal opinion.
For our baseline sentiment classification, we introduced 3 key innovations: ABSA, NER-enhanced classification, and an ensemble voting strategy. Aspect-based sentiment analysis focused on the coin listing feature, an important and balanced aspect in our dataset. Using vendor sentiment scores and a random forest model, we achieve a remarkable 99.6 accuracy, highlighting the power of aspect-specific classification. Secondly, we apply name entity recognition, filtering review that mentions specific entities like exchange names. This added semantic clarity, and after rebalancing with SMOTE, the classifier reached 60.8 accuracy, outperforming the baseline. Finally, our ensemble model combined predictions from random forest, naive Bayes, Vader, and TextBlock. Despite some weaker individual performance, the ensemble achieved 64.8 accuracy, demonstrating the benefit of diverse model aggregation. Ablation study demonstrates the impact of each innovation on the baseline, ensemble voting confirming that the combined diverse model helps to capture complementary patterns in the data.
Here's our crypto opinion search engine. Users can start by clicking on one of the suggested queries like Binance fees, or they can enter their own, such as Bitcoin. Pressing search returns the top 10 results. Clicking on the plots button shows visual insights on the results. Clicking on a result card, for example, opens the documents details page with more in-depth information. Clicking on the back to search results returns the user back to the search results page. Let's now test the spell check feature. If I type Bitcoin with a typo and click search, no results are found, but we're shown spelling suggestions at the top over here. Clicking on one re-triggers the search with the corrected query. Now let's explore the advanced filters. Suppose I want to obtain this record here only in particular. Note the attributes. Let's go back to the home page, type in highs as the query, and set the advanced filters. Upon searching, we get that one particular result and we can verify it via the plots. Demonstrate the relevance feedback feature. Let's say one record is ranked lower. By clicking the thumbs up icon, we signal its relevance. This updates its relevance score, which affects backend ranking. Upon repeating that same search, the record is now ranked higher, showing how feedback improves future results.